Here we have a problem on poles of a system. To find the poles of a system, which is described by the differential equation d square y of t by dt square plus 4y of t is equal to 6r of t. It's a linear time invariant system. The input is considered as r of t and the output is considered as y of t. So we are asked to find the poles, which are also called as the roots of the denominator of the transfer function. So it is important for us to find out what are the requirements to find the poles of a system. So we need to, because we are given a differential equation, a second order differential equation, we need to apply Laplace transformations to convert the time domain into S domain, and eventually we will find out the transfer function y of s by r of s. So solving for the roots of the denominator is the important point here. So this coming to the solution, applying Laplace transformation on both sides of the given time domain equation, which is d square y by dt square plus 4yt is equal to 6rt. And since we are going for Laplace transformation, we will be getting initial conditions also while converting the time domain into frequency domain. But since we are going for transfer function, we should be, by definition of transfer function, we should assume initial conditions to be 0 to determine any transfer function. Therefore, for a Laplace transform of d square y by dt square, what will be the result for this Laplace transformation of d square y by dt square? It is s square y of s minus s into y of 0 minus y dash of 0, where y of 0 and y dash of 0 are the initial conditions. But since we are assuming initial conditions to be 0, the Laplace transformation of d square y by dt square is equal to s square y of s only. So we can say the Laplace transformation of d square y by dt square is equal to s square y by y of s, and Laplace transformation of 4y of t is equal to 4y of s, and Laplace transformation of 6r of t is equal to 6r of s. So from this we can derive the transfer function, which is nothing but y of s output variable and r of s input variable. The ratio of these two can be obtained as 6 by s square plus 4. 6 by s square plus 4. And to find the poles, we need to find the roots of the denominator of the transfer function, which is s square plus 4. So if you equate s square plus 4 equal to 0, then we get s is equal to plus 2j and minus 2j. Therefore, the answer is plus 2j and minus 2j, which is the option D. And this problem is given in GATE 2020.